Hello to everyone. My name is Sandeep. I am working as an assistant professor in the Department of Information Technology of MLR Institute of Technology. So, in previous class, we discussed that different types of operators and also what is an operator, and we discussed that the arithmetic operators, comparison operators, which we can say relational operators, assignment operators, logical operators, like that one we discuss. So, and today we are going to discuss the remaining operators, which are identity operators and membership operators. So, what is an identity operator and membership operators? We'll discuss one by one. First, we'll discuss about what? Identity operators. So, identity operators are a special type of operator present in Python. Yes, it is, we can consider these operators are very special to the Python programming language. Anyway, what is the purpose of these operators means, we'll discuss through an example, right? Or otherwise, see here, what is the purpose of these identity operators means, they check, that means that identity operators check if the values are located the same part of object or memory. Same object or memory. Okay, for example, A equals to 10 and B equals to 20. A equals to 10 and B equals to 20. Now, actually here we have to discuss one thing. In Python programming language, that object creation is in different manner. That means if you want to understand these identity operators, then we have to understand how the Python virtual machine create an object in Python. See, for example, first the Python virtual machine are executed this statement. At that time, the Python virtual machine directly not going to create an object. First, it will check that memory, either that is whether that object with the same value is existed or not. That means whether any object with the value 10 is existed or not in the memory. If that object is not available in the memory, that means if that value is not available in the memory, then a new object will be created. So first, what will be happen, whenever this statement is executed, then the Python virtual machine won't create an object directly. First, it checks whether an object with the value 10 is existed or not. Is existed or not. If that object with the 10 value or with the value 10 is not available in the memory, then only the Python virtual machine create an object. So, for example, just consider here that object is not available in the memory with this value 10. At that time, the Python virtual machine creates an object, and in that object store the value 10 and refer that A. Next, value B. For example, now value B is also 10. Just consider the value B is also 10. Now, whenever this statement is executed, same scenario will be repeated. That is, the Python virtual machine won't create an object directly. First, it checks whether an object is available with the value 10 or not. Whether an object is already existed with the value or not. Like that, it will check in the memory. If that object with that value is not there, means then it will create a new object. But here what happened? Already that object, that value with object A is available. Already an object is existed with the value 10. Now what will be happen means, simply that object will refer to like this one. It won't create a new object. That object will refer to that object name, that is B. Why? Because of in that memory, that value 10 is already available in some object. Now, by referring that object, it does not own or it does not create an object. By referring to that object, it does not create a new object. So this is the scenario that object creation in Python by Python virtual machine. Right? Now see, A is 10 and B is 10. Now A is B. Why? Because of is an identity operator and another operator is not operator. Is an one operator and is not is an another operator. This is the two types of identity operators in Python. Now is operator. Now A is B. What is the is operator performance or operation? It returns true if the operators are identical. Yes. Now for object A and object B, are that A and B having same object value or not? That's why it returns true. Yes or no? Here say according to this one, right? And A is not B. What is it returns true if the operators are not identical? It returns true if the operators are identical. It returns true if the operators are not identical. That means opposite. Is the opposite operation performed by the is not operator. It returns true if the operators are not identical, but A is not B. But these two operators are what? So these two operands are what? Identical. Or these two objects are identical. That's why it returns what? False. That's why it returns what? False. So a little bit confusion will be there here. Why? Because of is operator returns true when if the objects are identical or if the operators are identical. Next, is not means returns true if the operators are identical, otherwise it returns false. Otherwise it returns what? False. So let me see an example. Right? Now see, A equals to 10. Now B is also 10. Now how many objects here created? Only one object, and that object is referred to the two operands, that is two variables, that is A and B. Now print A is B. Now A is B means A and B are two identical objects. A and B are two identical objects or not? Yes, two identical objects. That's why it returns what? True. Next. Print A is not B. A is not B. Now what is this one? When is not means what? Whenever the two objects are identical, not identical, it returns true. But here the objects are identical. That's why it returns what? False. So this is about what? Is and is not. For example, let's see another scenario. For example, B equals to 20. So whenever A equals to 20 and A equals to 10 and B equals to 20, now the two objects will be created by the Python virtual machine. Two objects will be created by the Python virtual machine. So now see, that's why A is B means two different objects, right? That's why it returns false. And A is not B means A and B are not same identical or not identical object. That means same object. That's why it returns what? True. That is, see, I will explain through this an example. Now A equals to 10 and B equals to 20. So now Python virtual machine, whenever this statement is executed, directly it won't create an object. First it will check whether there is any existing object is available with the same, that is 10 value or not. If it is not there means then object will be created and refer to A. Next, this statement will also be executed. Now see here that now the Python virtual machine won't create object directly. First it will check the memory whether is there any existing object with the value 20 or not. But now in the memory it is not there. That means there is no object with the value 20. Now an object will be created and referred to the B. Now tell me, A is B. That means A and B are same objects? No. That's why it returns what? False. Next, A is not B. A is not B means A and B are not same objects. So that's why it returns true. See, that's why it returns true. So the same thing we seen here, right? And then output here is false and then true, right? So this is about what? Identity operators. Next we have membership operators. So membership operators means it is also considered a special type of operators present in Python. It is also considered a special type of operator present in Python. Anyway, here also two types of operators, that is in operator and not in operator. In operator and not in operator. Now see here, what is the purpose of the membership operator means? It is used to check a value if that value is present in the sequence or not. The sequence means that may be a list or that may be a tuple or set like that one. For example, if you consider a list now 10, 20, 30, 40. Okay, na? 10, 20, 30, 40. Now 10 in list. That means the 10 value is present in the sequence. Yes. If the value is present means it returns true. If the value is not present in the list, then it returns false. Okay. So now let me check through an example, that is programmatical example, by taking the sequence, that is list sequence only I am taking. So 10, 20, 30, 40, 50. Now print. So directly I am going to perform the operation and then now 10 in list. Sorry, what is the object name? LST. LST. Right here the value is 10. Now, so the 10 value is present in the sequence or not? Yes, that value is present. That's why it returns what? True. For example, print 60 in sequence. That is sequence name is what? LST. Now see, so that 60 value is not present in that sequence. That's why it returns what? False. So that is the purpose of in operator. And next, which operator we have in the membership operator means not in operator. It returns if the value is not present in the sequence. Just opposite operation will perform that not in. Opposite of in operator. So not in means opposite of in operator. In operator is what? It returns true if the value is present. But not operator is what? If the value is present, if the value is present means it returns false. If the value is not present means it returns true. So that is the thing, right? For example, here the value is not there, that is 60. Now the 60 is present in the sequence? No. That's why it returns what? True. That's why it returns what? True. So let me see an example. Right, so print 60 not in list. Not in list. Now see, so the value is not there in the list or not in the sequence. That's why it returns what? False. For example, print 20 not in sequence. Now let me check. Yes, 20 value is present in the sequence. That's why it returns what? What it returns? False. So this is about what? Membership operators. So next, anyway, this is about identity operators and membership operators. Next very important concept we have to discuss here is precedency and associativity of Python operators. So what is the precedency? Precedency means, as we discussed just now, the priority of the operators. Because of, see here, what is a operator precedency in Python means? For example, there is an expression a plus b divided by So divided by 2. Now or minus 4. Just imagine. Like that one we have expression. So this expression, what it contain? More than one operator. For example, A plus B. So here A plus B means only one operator. So that's why the Python virtual machine won't confuse directly. It perform that addition operation. But here that expression contain more than more than one operators. At that time, the Python interpreters or compilers will get confusion. First, which operation we have to perform, and next, which operation we have to perform next. So, for that purpose, we have the concept. To overcome this problem, we have the concept that is operator precedency concept. So, this operator precedency concept here is based on the priority of the operator. First, the Python virtual machine or Python compiler has to perform that operation, and next has to be performed the next level priority or next level operation. So based on the priority of the operator, the operations has to be performed. The operation has to be performed. For example, here plus operator is there, and division operator is there, and subtraction operator is there. So among these three operators, which operator has highest priority means the division operator is the highest priority. That's why the division operator first will be performed, and later plus operator, and later subtraction operator. So like that one, that operator precedency concepts will be useful. Next we have one more thing, that is operator associativity in Python. What is this operator associativity means? For example, if you take A plus B minus 4. See here, plus operator is there and minus operator is there. Of course, as we discussed, this expression contain more than one operator. So now we have to, that Python virtual machine has to decide which operator has to perform first. So it will take that operator precedency concept. But in the operator precedency concept, the plus addition for addition operation and subtraction operation having same priority. So at that time, it will get more ambiguity. So it will get what? Ambiguity. Which operation has to perform, because of these two operators having same precedency. That means same priority. So to overcome this problem, we have that associativity rules. So these associativity rules are two types. One is left to right associativity rule and right to left associativity rule. Okay. So here see that use operator associativity when an expression includes two or more operators with the same precedency, like this one, A plus B minus 4. So here that is plus symbol and minus symbol or minus operators having same precedency. At that time we have to use what? Operator associativity, that is either left to right associativity or right to left associativity. So left to now. Next see, for this expression which associativity rule we have to follow, that is either left to right associativity or right to left associativity. Means we have to follow left to right associativity, because almost all operators expect exponent operator. Remaining all operators will support which associativity? Left to right associativity. So that means A plus B minus 4 here having two same priority or same precedency operators. So at that time, which associativity we have to follow? That is left to right associativity. That means first we have to perform that addition operation, and next we have to perform what? Subtraction operation. Why? Because of at left side, which operation is there? Plus operator is there, and then right side is what? Subtraction operator is there. So that is what? Left to right associativity. So this is the precedencies and associativities of Python operators. Next here see, finally this is the precedence list. First highest priority here is parenthesis, and next one here is exponential. Next complement, that is unary plus and unary minus operators. So what is the unary plus and unary minus operators means? For example, if you take A and we are going to perform minus. So whenever we are going to perform an operation on a single operand, that is called unary minus operator. And whenever you are going to perform a single, that is addition operator on a single operand, then that is what unary plus operator. So like that one, next precedence is here, next like that one. So bitwise, comparison, equality, identity, membership, logical operators. So this is the order of the or priority of the operators concept. So anyway, we'll see an example through a program. Now see, for example, A equals to 10, B equals to 20 and C equals to 5. Now we'll take a simple expression A plus B division what we can say 5. So now according to the precedency operators, just now we seen what is the highest priority. It contains more than one operator. Now according to that one, what is the highest priority? So division operator. What is that one? Division operator. So first it will perform the division operator or division operation, and then it will perform the addition operation. So 10 plus 20 divided by 5. So first it will perform the 20 by 5. So what is the 20 by 5? 4.0. So 4.0, next 10 plus what? 4.0. What will get? C. 14.0. 14.0. Right? So this is the, actually if we perform from left to right means first what is that one? 10 plus 20, 30. 30 by 5, 6 or 6.0. But it is wrong answer. So we have to perform what? According to the precedency of the operator. Then we will get the right result. So that is what. Next, for example, B minus C. Now see, this expression contain more than 2 operators. Now how many expressions we had? So one expression but 2 operators. But these 2 operators having same precedency. At that time what we have to choose? Associativity rule. Which associativity rule? Left to right associativity rule. So first it perform what? Addition operation, and then it perform what? Subtraction operation. Now see, 25 because of 10 plus 20, 30, and 30 minus 5, 25. So this is what about precedencies and associativity rules. This is about what? Python operators. Next we will discuss the another topic, right? So thank you.